So as I just said, as we were waiting for that to save, I'm going to try and show you a three-dimensional beginning to the problem, convert it to 2 dimensions so that we can actually do the problem, and then return it to 3 dimensions by revolving it around an axis. But are we actually going to physically revolve it? No, we're going to let the calculus do that for us. So if this was obviously there's a ball bearing, if this was a drill, it would come in here and basically turn it into a 2-dimensional version like that. Agreed? Would it still technically be coming out at us and going around? And going back out and around? It would. But what I've done is I've taken it to a 2-dimension. But what can you tell me about that and that? They're the same. So could I just say, well, forget about you, I'm just going to deal with that one up there, and I will revolve that around the axis, which would be right about there. If I were to take this and revolve it around that axis, I just put it in a dotted line, would that give me basically a ball that has a hole drilled through it? It would, because you don't need both of them. If you just have one of them, this one would come around and create that. And that's the problem we're going to do. But what we have to figure out is, where did we start? As you look at it, we know some of the information. I mean, we know that the radius of that right there, if this was just a circle, we know the radius is 5. Now, could I put that circle wherever I wanted to on an XY axis? I could, but where's the smartest place to center that circle? At the origin, isn't it? Isn't that the smartest place to put the center of that thing? So if here's your XY axis sitting there like that, we know that this distance is 5. We know that distance is 5, 5, 5. All that thing works out. Now, do you remember back to section 9-8 in geometry, which we just got done doing, of how to write the equation of a circle? Okay. You may or may not, but what it was is we did stuff like this. You know, x minus 1 squared plus y minus 2 squared equals the radius squared. You remember stuff like that? Look at least vaguely familiar? I know it's been a while, but this one would be centered at 1, 2 with, let's put a number in there for you as a good refresher. Let's say I had a 16 in there. This circle would be centered at 1, 2, because it's always the opposite of what you think when it's in parentheses squared. So 1, 2 would be the center with radius 4. So can we come up with an equation that would give me this circle that I just pretty much created for you? Can we come up with that equation? Okay, equals 25. That's a good start. Close. There's the equation of that circle, because the center is 0, 0. Did we have to put anything in those parentheses if it's 0, 0? No. And radius squared we know is that. Now, we do know that the hole has a radius of 3, so we know basically I want it to cut through here and cut through there. But remember, do I really care about that? No. So how could I make the radius 3? I have to cut it right there, correct? And how far is this? We know that happens to be 3. How can I represent this horizontal line? That's much easier than what we just did. Don't even have to do that. We just have to represent that horizontal line. Y equals 3. Okay. So those right there are our 2 equations we're going to use to create this problem. Okay. And in other words, if you look at it, it should look something similar to that. And I gave you that. And we know our 2 equations, as I just wrote on the other page, are x squared plus y squared equals 25 and y equals 3. You notice I chose to only draw in a portion of that graph, because would your circle technically keep going around like that? Yes, it would. But do I need the whole thing? No. If you'd like to draw the whole circle in, go right ahead. But what we're going to do is we're going to take this area right there, and we're going to revolve it around the x-axis. Will that create a ball with a hole drilled through it? Most definitely. In fact, it might even be a little sharp right there on the corner. That is the equation of that circle that I just had up there, of the entire circle. Or when we had it back here, it is the equation of this entire circle, is x squared plus y squared equals 25. Okay, because the center is 0, 0, and the radius is 5. Okay. We have a slight problem, though. That first equation. Yeah, don't we normally have like y equals or x equals? If we're going to go this way, do you agree our rectangles will be, the easiest way to do it is to put the rectangles this way, which means they are dx, which means I want it solved for y. Okay. because we are doing it with respect to x, which means x better be the variable we're using in the problem. Okay, the question is, can't we just do dy on this one and do the entire thing times 2? Well, then you would have the area of that and the area of this, but not the volume of the whole thing revolved. So unfortunately, no, we cannot. Good try, though. Solve that for y. Shouldn't be too hard. You should be able to do that in your head. Solve that for y. Seeing it's a sum? No.
Square root of 5. No, it could be 20.
Okay, so let's do the algebra. Get y by itself. Then you take the square root of both sides. And of course, we all know that when it's subtraction or addition, you cannot take the square roots separately. Because if you could take the square roots separately, the answer to that question would be 7. If you could take the square roots separately. I hope we all agree the answer to that problem I just put in black is not 7. So when there's addition and subtraction involved, you can't take the square roots separately, which means that right there in green, y equals the square root of 25 minus x squared, is the equation of that top piece. So now that we have that straightened out, yes, this will be on the recording for eternity, some of the answers that you tried to give. So in other words, what we're trying to do is, in a way, that. That is, again, only 2 of the possible washers that could be made. But that is what it will look like. Again, it will be a ball that has a hole drilled through it. So again, what I like to figure out before I even start is that. Big R is basically, if I set an x value of 1, big R is big R. That distance right there is the question. Is that actually big R? Yes, it is. Because we are going around the x-axis. If we were not, that would not be big R. But seeing we are, well, it is. So big R is the square root of 25 minus x squared. Little r, if we go here, little r is that. So in this case, does big R change as the problem moves left to right? Does little r change as the problem goes left to right? Not really. Isn't it 3 pretty much the whole way? Okay, even if I try it over here, isn't it 3? All right, so little r is 3. And here is where you could make a huge mistake. And once we are done with this problem, I will show you why that would be a big mistake. We should have time. I think I can erase this now. I think we've got that figured out. So volume, pi. Now from where to where could get interesting. Now let's say I didn't have it graphed really nicely for you at -4 to 4. How would you figure that out? Yeah, set these two, in this case, set those two equal to each other and find out where it happens. What x value does it happen at? So it is -4 to 4. Big R.
25 squared.
Very good. Square. I was going to see after all of this that we have done, I was going to see if you remembered that you had to square it because it is pi r squared minus another pi r squared. This one is much easier. Little r. Or you could just say 9 exactly. And dx is your width. It says I'm going from -4 to 4, and along the way I'm putting in a bunch of x values. Based on the notation, am I integrating yet? No. I would simplify. You've noticed a lot of square roots happening, but that's because I haven't really tried to avoid them because I'm going to just square them in the problem anyways. And I personally wouldn't even integrate yet. You can even make this easier before you integrate. And what I would like you to do is finish this one now. No, for like the next couple minutes. All right, bringing us back together. I heard the correct answer out there in a variety of forms, but it is the correct answer. What I have here is 256 pi over 3, which is, what, 85 1/3 pi? And so all of those are acceptable. Please realize, if you are asked to get the exact answer, the only way you can just check your answer by using the calculator, but you can't be sure. Now, a very easy mistake to make, which is why I got the washers out of there, so that you don't have to look at them. Here's what some people think. So everybody's attention up here. Again, sometimes it's easiest just to look at one particular x value. For example, I think we all agree that that was big R in this problem, because that was basically as far as it could go. But what some people look at it as, and incorrectly look at it as, is saying, well, why don't I just take big R and subtract the 3? Well, that would be true if all you were looking for was that distance. And if all you were looking for was that distance, you could take that rectangle and you could revolve it around this, and that's the problem we did on day 1 of this. We revolved it around here. You see what I mean? How radius is starting to get a little bit more complicated on how to figure that out. That's why we had it here squared minus that squared, because we were actually subtracting volume here, not just distance. Do you understand the difference between those two? Here I was trying to take the blue distance and subtract out the green distance to actually find the radius, because it wasn't just the function anymore. That y value from the top of this to this little red line was much more difficult to figure out. So as I move this axis of revolution, this could potentially get harder. Exactly, and we are cubing it because we are squaring here and then taking it times itself again. We are actually cubing it when we do it this way, where even we would here if we did disk method on that one. And this is very similar to that second example on day 1. It's very close, and that's why I did that one. Okay, so you need to know, am I just subtracting to find distance, or am I subtracting volumes like I am here? If you can keep those things straight, you'll be fine. But I'm not going to tell you that finding the radius is easy. I even told you already, it's the #1 most important question to be able to figure out. Because after that, it's just substituted in. The radius can get hard. And just imagine some more fun. What if the axis of revolution is up there? So keep that all in mind.